Okay, good morning. Welcome to my talk about Nightwatch, which is a testing framework written in JavaScript, designed for web developers. A little bit about me. My name is Seth McLaughlin. I am mostly a front-end engineer. I work a little bit on the back end as well. While I was at LinkedIn for a couple of years, I worked on a couple of different testing frameworks. We developed a framework called Venus.js, which is more focused on unit testing, JavaScript code, which is not what we're talking about today. And I also worked on the central QA team where I helped out with some of the core Selenium testing infrastructure for LinkedIn. And currently, I'm working for a company called Shape Security. We're a web security startup based out of Mountain View. So the topic of today, of course, is Nightwatch. So what is Nightwatch? It is a project implemented with Node.js. And it basically allows you to write functional tests. So just a quick show of hands, how many people are either QA engineers or write functional tests today for their job? Great. And out of you guys, how many of you actually use JavaScript to implement those tests? OK, a good number. Do you guys use Nightwatch? OK, not as many. A couple. OK, cool. So this morning, I want to talk about three main things. We're going to do a quick project overview just to introduce Nightwatch for those of you who maybe haven't heard of it or aren't familiar with where it came from. And I'll list out some of the features it supports so you can kind of compare that against other tools that you may be using today. And finally, I want to show you some code samples to give you a flavor of what it feels like to write tests with Nightwatch and how you can go ahead and actually get started yourself if you're curious to check it out. So first, let's talk a little bit about what exactly is end-to-end testing. Most of you are probably familiar, but just in case you're not, end-to-end testing is designed to allow you as a developer or as a test engineer to write automated tests which capture users' interactions with your website. So for example, you might be testing that a user can log into your website. So this level of testing is very, I would say, black box, in that you don't really care or need to understand how the code works. You're basically just automating a browser to go through the same actions that a user would take when they're interacting with your website. And it's really useful to automate this because, say you're working on a web app, every time you deploy, you don't want to have to test these scenarios over and over again manually. You'd much rather be able to just run an automation suite, maybe even automatically run it in all the major browsers you support, like Firefox, Chrome, Internet Explorer, and get some results that gives you confidence that you can deploy and there's no problem with your app. So in this case, if we were testing a login flow, we might define it as these 6 steps. We might say, OK, first, we have to open the browser and navigate to the login page. Second, we locate a form field, the username field, and we type in a user. Third, we locate the password field, type in a password value. Fourth, we submit the button. We click the submit button to submit the form. We wait for that form submission to complete. Perhaps it's a page load. Perhaps it's an AJAX request. And then you verify some aspect of the state of the resulting page to ensure that your action succeeded. Now, in this example, I'm just verifying that the page title changed. But you could verify that certain content is in the DOM or any number of things, which would be the success criteria for your test. So looking at a high-level architectural overview of how this stuff works, working backwards from the right, we have the web browser, of course, which is being scripted to perform these actions as a real user would. Then we have something called Selenium Webdriver, which is a tool which allows you to control the browser. And it's interesting that this started out as a kind of a third-party approach where there's different drivers that control different browsers, but WebDriver itself is actually becoming a W3C spec, so all major browsers should support it natively, which will be good because that will be just probably a lot smoother interaction than what we've seen in the past. But today you can use WebDriver with all the major browsers. And additionally, Internet Explorer 12 supports WebDriver natively, which is great. I believe they've backported it to IE 11 as well. And I'm told the spec will be finalized next, I think, I'm not quite sure if it was this year or next year, but it's making really good progress. And then, so the next step is you have some sort of test runner, and this is what Nightwatch provides for you. So this is something that will read in a test and then issue commands over HTTP to Selenium, which then gets translated into actual commands to control the browser. So these different parts that I've highlighted in the dotted lines could actually live on different systems and often do. OK, so Nightwatch itself, like I mentioned, is giving you these two components on the left. So it gives you an API for writing your tests. And your tests are actually just Node modules. So if you're already familiar with Node, it's pretty trivial to implement a basic test. And then the test runner itself is a Node.js application, which you can easily install with an npm install. It's important to note that, not surprisingly, Nightwatch will also work with Selenium Grid. If you're familiar with Selenium testing, you've probably either used Grid or know what it is. But essentially, what it allows you to do is manage a pool of browsers. So then you can, when you start up a test, your test runner just talks to the grid and says, hey, I want to run my test with a node that has these capabilities. Like, it could be, I want Chrome, or I want IE, or I want Firefox, or I want this version of Windows to run the test. So what does Nightwatch offer you? First of all, I think it has fairly good documentation. It could, of course, always be improved. So if you're interested in this stuff, I highly encourage you to jump in and help make it better. But the author has done a very good job of getting a baseline of documentation. I think if you go to Nightwatch, the Nightwatch website, you'll have all you need there to get started. When you're actually interacting with your page, you can use either CSS or XPath selectors. Which is great, because if you're a web developer, you already know CSS, and it's pretty easy to script those tests. The test runner itself can execute tests either sequentially or in parallel. So parallel execution is nice, because it just speeds up the process of running all of your tests. And then you have some control over which tests get run. So you may have a large corpus of tests, maybe 1,000 different tests, but you only want to run a subset of those on every build or every release or something like that. So you can either select to run tests by pattern matching the file name. You can organize your tests into folders. Or even more flexibly, you could add tags to your tests and then say, OK, I'm going to tag test A, B, and C as sanity, so I always run those tests, for example. I think this is pretty much expected in this day and age, but it also integrates with cloud providers like Sauce Labs and BrowserStack. So this is really great, because if you're a small team or a small company and you don't have the internal resources to set up your own test lab that's running all these different OSs with all these different browser versions, you can sort of outsource that to Sauce Labs, and they'll provide any browser you want, basically, to run your tests. It also features JUnit XML formatting for test results, which is pretty standard. So if you're using a continuous integration system like Hudson or Jenkins, for example, it can already read this test format. So it's very easy to integrate Nightwatch with your existing workflow. And finally, there is an extension model. So if there's a particular API or feature that you don't see in Nightwatch, you can go ahead and implement that yourself, and there's fairly good documentation around that. And I'll show a couple of examples of doing that, just that. So who created Nightwatch? So it was created by a guy named Andre. He actually lives in Norway. And he started working on this project, as far as I can tell, about 2 years ago. But it really seems like it picked up speed in late 2013. He goes by the name of Beat Factor. And if you're interested in learning more about what he does, he's a front-end developer. And you can check out his LinkedIn profile, which I've linked to at the bottom here. So a couple of quick stats. Looking at NPM, we can see that it's fairly popular. We've got 9,000 downloads roughly last month. It's not huge, not anything compared to Mocha or some other testing libraries, but I think it's definitely growing. I gave this talk last June, and at that point in time, it got about 5,000 downloads a month. So we're definitely seeing a trend towards adoption. A lot of stars on GitHub, a lot of forks, fairly good code coverage, which is important, and you'd probably expect that coming from a test framework should be tested, right? And it's also under active development. We can see at the bottom here that it was last updated 5 days ago. A couple more stats. A fair number of contributors. There's fairly healthy pull request activity. There's one that's kind of been hanging around for a while. a bunch of open issues. People are using the tool, filing issues, and issues are getting fixed. So that's always good to see in an open source project that you're thinking about adopting, because you want, if you're going to actually use this, at your job, you want to feel like it's being supported, and you'll have somewhere to go to get help if you run into issues, or just want new features added to the tool. So drilling a little bit more on contribution activity, like I mentioned, it's really more in late 2013 where stuff really happened. It looks like maybe Andre created the repo back in 2012 and then really just let it sit dormant for quite a while. But in late 2013, it really picked up speed, and there's been a lot of activity ever since. I've helped out a little bit with the project. I implemented the test tagging feature, but you can see from the commits that is predominantly Andre writing the code for now. OK, so going back to our simple example, let's look at how we would actually implement a functional test to test this user scenario of logging into a website. So first thing we'll look at is our project directory structure. So you could, of course, if you're already building your web app as a Node.js app, you could just store your test files in the same repo or the same directory structure as your project. I personally like to separate it out. So my projects start pretty simple like this. You have a Nightwatch Js file, and that's your configuration, which we'll look at in a minute. And then you have a test folder. And in the test folder, this is where you put your tests, right? So let's look at login.js, which is going to test that login scenario for us. So like I mentioned earlier, a test is simply a Node.js module. So very simple. You just create this object, and you can give it a descriptive name if you'd like. Like for example, here I use the name fillout form and login. And that is just a function which accepts this object from the framework called client. And client is what you call to interact with the browser, essentially. So first off, I'm using this API here, .url, which allows me to direct the browser to load this web page. And then I'm doing an assertion to say I expect something. So I expect the page title to equal this string, awesome app. And this is where I'm going to interact with the form. So I'm setting a value, and then the first parameter is the CSS selector, where I tell it which field I want to operate on. And the second parameter is the value. So I want to set that field to the value of Seth. I do the same thing for the password field. And then I have this click API, so I can very easily just click an element on the page. And again, using a CSS selector to locate that element. And then finally, I assert that after the page has loaded, or the form has been submitted, that now the page title is welcome, which is what I expect it to be when I've successfully logged in. And finally, it's important to call end, and that tells Nightwatch that you're done with the test, so it can close the browser and do any kind of cleanup that it needs to do. So pretty straightforward. So one thing that's interesting, this trips up a lot of people, especially if you've come from maybe using Python or Ruby for doing this type of testing. All of these API calls are asynchronous. So I've seen this a lot where people will basically send all these commands, and then at the end do something like console.log or some other operation, and they expect that console.log will be executed after all the previous commands have executed. And that's not actually the case, because what's going on here is every time we call client and calling API on client, it's basically queuing up that action. So the way to get around this is that Andre recently added a perform API. So you call client.perform, and that takes a function. And then you can do something inside of that function. And then that way, the console.log will be queued up to run after the assert ran before it. And you also have this done callback that you can call to let the framework know when you're done executing. So for example, we might want to, get some dynamically generated value for our test that's an async operation. So we can do that. And then when we're done, we just simply call done to continue the flow, the execution flow of the test. OK, so next let's look at the Nightwatch Js file, which is our configuration. So there's a lot of stuff in here. There's actually quite a few more options that I'm not showing on this slide. But the docs have very good documentation for all of these options. So if you check out nightwatchjs.org, you can find a great reference for this stuff. But just touching on a couple of them, probably arguably one of the most important options is telling the framework where your tests are located. So in my directory structure, I put my tests under the folder named tests, but that's arbitrary. You could store them wherever you want to. Then I specify an output folder, which is where my results will be stored. And here I define some information about Selenium. So Nightwatch itself does not come with the Selenium jar, but it will start it for you automatically if you want it to. And to do that, you have to tell it where the jar file lives on disk. So this is where I'm doing that. You can also specify where the Selenium log path would go and a few other things about Selenium. And here we can define our test settings. And each section inside of this block, so default would be considered what's called an environment. So I could have multiple environments set up in my configuration. Here I'm just configuring one environment. But I can tell it, for example, where to find Selenium. In this case, I'm running it locally, so I'm just using 127.0.0.1. But it could be running on a different box. And I can tell it some things about where to store screenshots. And probably most importantly here, I can tell it where, or excuse me, which browser I want to use. So in this case, I'm using Firefox. OK, so that's great. But how do we actually run our test? So that's also fairly simple. You install Nightwatch. You can either install it globally. In this case, that's what I've done. Or you can install it to your local project directory. If you're familiar with npm, to install globally, you just do npm install -g Nightwatch, and that would get installed. And so I run Nightwatch. I use the -c option to tell it where the config file is. And then I tell it which environment I want to use from that config file. And if I wanted to, I could specify the test tags to run or other options about which tests to run. But here I'm just running everything, basically. So once that runs, you'll get some nice console output where it will show you the name of the test suite login. And that's just derived from the file name itself. And then each test within that suite will be printed with results. So here I have my fill out form and login test. And each assertion that I made is printed out. And then a green check mark is displayed since that assertion passed. And at the end, it will tell me how many assertions passed and also how long it took to run the entire test. OK, so going back to our first example, anybody that's sort of familiar with writing tests, can you tell me what we might want to change about how we wrote this test? Like, is this a good way to write tests? Is there any anti-pattern that you can see here?
Before each.
Before each? Oh, for test hooks? Yeah, you could do that. But what I'm talking about in particular is these values. So they're hard-coded, right? Which isn't super flexible. One common scenario might be like, say you're testing a large site. I mean, we did this at LinkedIn, for example. So every time you run a test, you might want to have an API where you call to get a valid set of user credentials. So rather than hard coding your user credentials to log in with, you can call some service that says, hey, just create me a throwaway test account. So we want to make our tests ideally more data-driven. So we can do this fairly easily with Nightwatch. In this case, I'm going to show how you could do this just by storing the data for the test separately from the test itself. So a simple pattern to use is to create a data directory in your project directory. And then you can, here in this case, I've sort of split it up by test environment. So imagine you have a dev environment for locally running your tests, and then a staging environment where you have a staging server set up to run some final testing before deploying. So my dev.js is simply a node module. It's really a simple object where I can store key value pairs of data that I want to be able to reference from within my tests. In this case, I only have 3 values, so it's fairly straightforward. I'm going to store my username and password that I'm going to use for the test. And I'm going to store the URL of the login page that I actually want to navigate to during the test. I have to make one small tweak to my Nightwatch JS configuration file to make this work. So under the environment section, you can specify a globals key. And here I'm just requiring that file. So I'm setting globals to that object, basically, that has those values inside of it. So one thing I could do is I might want to create a separate environment called staging or something else like that. And then I would require my staging data file. So accessing this data from within inside of your test is very simple. There's a globals object that you can reference from the client object. So here I'm saying my data is equal to client.globals. And now I can just reference that within the test. So I'm using, when I'm selecting the URL to go to, instead of that hard-coded string, I'm saying data.urls.login, which is going to give me that string value for me. And the same thing here when I'm filling out my form. So I can say data.username and data.password to get those values. Another thing that you can do that's worth mentioning is you can actually split up your test into multiple steps. So here, I split up my test into 2 parts. First part, I'm filling out the form. And the second part, I'm submitting the form. So this might be interesting to do, especially if you have a very large test suite. If there's a lot of functionality, you can split it up. The other key benefit of doing this is that the entire sequence of steps within each section is fully executed before moving on. So this kind of helps you deal with some of those asynchronous issues as well. So in this case, in the fill out form step, I'm going to the web page, I'm doing an assert, I'm filling out the form, and then in the submit form step, I'm actually submitting the form. So this console.log message won't actually print out until the entire previous step is complete. So looking at the output of this, it's very similar. It's just that we've now split it up into 2 different tests or test steps. So we have fill out form with the results, and then submit form with the results. So terminology is pretty simple. The login file is referred to as a test suite. And then each of those sections are referred to as tests. So we have the fill out form test and the submit form test. Another thing that is useful to know when you're writing tests is what are your options for checking the state of the page. So we have 2 APIs. We have assert and verify. And they both let you check if something is true. And the key difference is that assert will stop the test if it fails, if the assertion fails. Verify won't. It will log the message saying this failed, but it will keep going. So depending on your use case, you have these 2 APIs to choose from. Another thing that's really important to know is how do you go ahead and debug your test. So you might write a test and you expect it to pass, but it's just not passing. You can't figure out why. There's a couple of options you can do. First, probably one of the most useful APIs is pause. So you can call pause on the client object. And this will, well, pause the test. And it will leave the browser window open, so you could then go ahead and dig into DevTools or just look at the page and kind of try to figure out what the heck is going on. The other option is if you're trying to debug your test code itself, probably the easiest way to do it, in my opinion, is to just use the debugger statement and then hop into the Node debugger to step through your code. If you're not familiar with the Node debugger, you can, there's a link at the bottom where you can look at the API docs. There's also some instructions on the Nightwatch website on how to set this up with WebStorm. So if you like more of a visual or GUI debugger, you can do that as well. Okay. Node inspect could work as well. Yep. So there's lots of commands available. It pretty much maps to a standard Selenium API for the most part. You can do things like check the attributes, get the attributes on an element, of course get the title of the page. Basically, you inspect anything about the page that you're currently looking at. You also have a fair number of assertions. And you can use these with either the assert or verify method, depending on what kind of behavior you want to happen if it fails. You can assert on things like, is an attribute on an element a certain value? Is something hidden? Is the page title an expected value? Is an element on the page? Is it not on the page? Et cetera. So there's quite a lot of flexibility in here between the commands and assertions. However, if you need to do something which is not already supported, you can create your own custom commands and assertions. So here's an example where I created a somewhat contrived example of creating a custom command. So in this case, I'm going to this web page, Netflix, and then tag count is a custom command that I created. And basically what this does is it lets me give a particular element type or tag, in this case an anchor, and then get a result of how many of those elements are on the page. Here I'm defining a custom assertion. So if I want to assert that there are at least 100 anchor elements on the page, I could do that with this API call. So this is showing how to use the custom extensions. And next I'm going to talk about how you actually implement those. So doing a command, I think, is arguably easier than doing an assertion. This is an example of how we would implement our tag name. So essentially, all you do is implement a node module. And it takes a callback, and then, in this case, a value mapping to the tag name that you want to check for. And so then we just call execute. And what this is doing is saying, I want to execute the following code within the context of the web page. Not within the node context, but within the actual browser that we're observing through this test. So this is one reason why I actually prefer writing my Selenium tests in JavaScript. Because if you're ever trying to inject JavaScript into the page, it's much more it feels much more natural since you're already writing the test code itself in JavaScript. Versus something like Python, where you're writing in Python and then you have to sort of inline some JavaScript. It's just personal preference. But anyway, so it's pretty straightforward. So that gets the values by calling get elements by tag name. And then we're looking at the length of that value that's returned. And then we call back with the results. I realize this is probably too small for most of you to see. This is an example of writing a custom assertion. As you can sort of tell from the length of this slide, there's a bit more code you have to implement to write a custom assertion. It's still not too hard. And I encourage you to check out the API docs. There's a great doc about how to do this for yourself. Additionally, at the end of this talk, I link to a GitHub repo that I put together where you can see all of this sample code that I'm showing you today. So the final step to actually using these extensions is to hook it up by referencing them in your Nightwatch configuration. So you just add two new values, custom commands path and custom assertions path, to tell the framework where your extensions live. So there's a lot more to explore with Nightwatch. It does support before and after test hooks, like most testing frameworks. You can take screenshots. As I mentioned before, you can use cloud services such as Sauce Labs to actually execute the tests, and a whole bunch of other things to explore. So I really encourage you to try it out if you're at all interested in functional testing, and give back to the community as well. So go ahead and, I know one user, for example, recently wrote a nice documentation about using the page object model with Nightwatch. So if you come across something that isn't documented well or you think could be explained better, just write some documentation. That's a great way to contribute as well. And getting started is really easy. Like I mentioned before, you just have to install Nightwatch with npm. Of course, a prereq to that is having Node installed, which is also fairly easy to get up and running. and then you download the Selenium jar separately, and then you configure your Nightwatch project, and then you just write some tests. So to make this process even easier, I put together a Yeoman Generator that you can grab, and that takes care of, there's like a Selenium wrapper, node module wrappers that will take care of like downloading Selenium jar for you and giving you a same default Nightwatch configuration file. So if you go ahead and use this, it's like really, really simple just to get up and running and write some tests. So a couple of closing thoughts. This is obviously controversial, perhaps, but in my opinion, Nightwatch JS is probably your best option for doing Selenium testing with JavaScript. I would love to be proven wrong. If any of you know of an even better framework, I'd love to hear about it. I think it's an area that is valuable to pursue because one problem a lot of organizations have is that their Selenium tests are written in Ruby or Python. And that creates a barrier to entry for web developers to actually start helping out and writing tests because they may not know those languages. Whereas if we use a language like JavaScript, which we're all really familiar with already, it's much easier to get started writing tests. Like I said before, it's got a really good community, a lot of activity on the GitHub repo, and it's really trivial to get started. So go ahead and check it out. Here are some resources that you can use to help you on your journey. There's the guide and API docs on the official website. I've got the GitHub repo for this talk with all the code samples up there on GitHub, as well as the Nightwatch generator for Yeoman. And finally, Nightwatch does have experimental support for a page object model, which I didn't talk about too much, but if you're familiar with Selenium testing in general, the main idea behind a page object model is that you encapsulate the interaction with a particular web page in its own file, and then it kind of serves like an API to the web page. So rather than hard coding your CSS selectors in every single test that you write, you can just include this page object and say, like, get me content from search results or something like that. So check that out. The official documentation doesn't have anything about the page object model yet. It was implemented fairly recently. But a user did go ahead and write some pretty good documentation, which is on a GitHub issue right now. And hopefully, Andre will incorporate that back into the main documentation site. But you can find that at the last link below. So that's pretty much all I have. But I saved time at the end for questions. So if anybody's curious about anything that I've talked about, please feel free to ask some questions.
Does it just use WebDriver JS underneath and like sugar that?
Yeah, good question. So for the communication with Selenium, does it use WebDriver JS or another existing module? No, last time I checked, it does not. He actually implemented his own client for the API.
Probably get this question a lot all the time. For those inside infrastructure and Nightwatch
Oh, OK. Yeah, so the question is, if you look at some other frameworks like Protractor, how do you decide between that option versus Nightwatch? To be perfectly honest, I haven't looked into Protractor too much. If anybody here has experience with it and can offer some insight on the kind of pros and cons, that'd be great. But I honestly am not sure. My understanding is that Protractor is designed to be very, very good at testing Angular apps. And I assume it would work with other apps, but I don't really know. Yep.
Two questions. One is like a general question, another is a detailed question. The general question is, how well does this stuff play with like Circle and Travis? And the second detailed question is, it seems like when, I don't really understand why you have to do that stuff, kind of jump through that hoop for the globals instead of just requiring the data file directly, with just the standard sort of require the data file.
Yep. So I think two questions. First part was about continuous integration, how it integrates with existing services like Travis and Circle CI. So I've used it with Travis. It seems to work fine. I imagine it would be similar experience with Circle. Second question was for the global data. or the globals, why did I use the globals option in the Nightwatch config instead of just requiring the data object directly? So one reason is that you can take advantage of the concept of different environments more easily. So in the Nightwatch config, you define, in this case, I just had one environment, the default environment, but you might have multiple ones, like staging, test, I don't know, other environments that you want to configure. And that just kind of takes advantage of that existing nomenclature. So I know, OK, I'm in my dev environment because that's been selected when I invoked the framework. And now I automatically get that data set. So that's the only reason. You could totally just require the object a more traditional way as well.
One thing I think I saw was that you can basically inject JavaScript code into the page.
Yes. Yep.
Kind of a corollary to that is one complaint I've heard against Selenium testing in general is that it's slow because every time you make a request, it has to do this round trip to the browser.
Yes.
Is there any support built in for assertions that you can run sort of client side and then, almost like a batch group of assertions and then send it back?
Oh, OK. OK, yeah, so I think the question was, first of all, performance, generally Selenium tests. Yes, generally Selenium tests are relatively slow, certainly much, much, much slower than unit tests. Nightwatch tries to help out with that by allowing you to execute tests in parallel, which helps somewhat. I think the second part of your question was, is there some notion of doing assertions client side rather than on the node side, in which case you have to kind of cross that barrier to the client every time you make the assertion? There's not that I know of, but that actually is a really interesting idea.
So have you tested any difficult things like drag and drop interfaces with this? And do you have any thoughts or tips around that sort of thing?
So have I tested anything more complicated, such as drag and drop UIs? I actually haven't. I know that you can hook up to pretty much any mouse event or type of DOM event. So in theory, it's totally possible. I can't really comment as to how complex it would be to implement, though. But that's a good scenario to think about. So maybe you should go home and try it out and then post to the project. Yep.
Anyone tried using it with Cordova apps?
I'm sorry?
Support for Cordova apps.
For native apps?
Yeah, Cordova apps, yeah.
Cordova.
For Cordova apps? Not that I've tried. I don't see why it couldn't work. I know that, was it the guys at Yahoo that created a Selenium driver for Cordova? I can't remember, but I would imagine that it.
You can use
Appium.
Which implements a Selenium protocol for the mobile apps. Not sure if it's Nightwatch.
OK, great. So you can use Appium as an option.
You use Appium. I was just wondering if anyone had tried using Nightwatch.
I'm not sure, but again, try it out.
What's that?
I did. I tried it. It was
Okay.
Cool. We have an expert from Sauce Labs here, so if you have any questions about Sauce.
I'll talk to you about the config files.
OK. Well, thank you very much. I'm going to stick around for a little while, so if you have any other questions.